So for this one, we've done something a little weird. On the left, we have a rational expression, numerator and a denominator. But on the right, it's just a polynomial. We don't have a numerator and denominator. It's just this one thing. Now, you've seen this same circumstance show up when you did regular fractions. So you should, if you think about it, know what we're going to do to set this up. There's one very, very simple, basic little thing that we can do to change how this looks to make it look just like all the other problems we've been doing. So who's got an idea here? It's something that you've done with regular fractions as well. Julia? Put it over 1. This is the exact same thing as saying a fraction times a whole number. So we're going to take this whole polynomial and put it over 1. And by doing that, we've created numerator, denominator, numerator, denominator. So now we follow the same steps we were doing before. So let's do a whole bunch of factoring, cross out whatever we have, and then multiply it all together at the end. So real quick, this numerator, 2m plus 5, do they have anything in common? No. Does it have m squared? No, it does not, so let's leave it alone. The denominator, 3m minus 6, do they have anything in common? They do. What? 3. They're multiples of 3, so this becomes m minus 2. Okay? This numerator, m squared plus m minus 6, do they have anything in common? That should always be the first question. No. But does it have m squared? Yes. So this is an X method problem. We are multiplying to make negative 6. We're adding to make 1. Raise your hand if you know these numbers. Naomi? 3 and negative 2. So my new numerator is going to be m plus 3 and m minus 2. And the denominator is just a 1, so we don't need to try to factor that. So at this point, we take a look. Anything that we feel we can cancel, we're going to do that. There should really only be one thing that seems really obvious, and it's actually the only thing we can do in this problem, Bella. M minus 2, that's it. Those two binomials match exactly. Nothing else can be reduced. It's very, very tempting for some people to say 3 here and 3 there. Don't do it. This 3 has been factored out. This 3 is part of a binomial. They cannot be used separately. So, take a look at what's left. The denominator is real easy. The only thing left on the bottom is 3 times 1. We've got that. In the numerator, I have 2m plus 5 times m plus 3. Some people get a little confused when they look at this because they don't see that this should have parentheses around it, which makes it, again, a FOIL, box method, or distributive property problem. So let's multiply these two things together real quick. Does not matter what method you use, FOIL, box method, or distributive property. We should get 2m times m is 2m squared. 6m and 5m will make 11m. And 5 times 3 is going to give me 15.